It was 1976. A mere couple of years ago, the first truly affordable, truly personal microcomputers had begun to appear, although what had been offered thus far was hardly user-friendly. The first home computers barely resembled what we'd think of as a computer at all. Their input and output were basically an array of switches and LEDs. Their capabilities were barely more than a glorified calculator, at least until teletypes, serial terminals, and EEPROMs came along. But a couple of very smart guys were working on something to take us to the next level in building one of the first computers to really look like what we'd think of as a personal computer, or rather, maybe a computer that looked like a typewriter that eventually became what we thought a computer would look like, or something. Anyway, their efforts would culminate in one of the best looking 8-bit computers of all time, in my opinion, the Sol-20 terminal computer. But this video is actually about the prototype of that machine, which wasn't even technically a computer, the Sol Intelligent Terminal, and how I'm about to attempt to build a replica of that unit that appeared on the July 1976 cover of Popular Electronics magazine 46 years later. Welcome to the inaugural Raising the Digital Dead episode, where we attempt to resurrect projects from the pages of old magazines, books, and anywhere else I can find them. In these series, I will attempt to build long-forgotten digital devices that sometimes survive only in print form today, and we can all commiserate with the ghosts of projects past. Hopefully they be friendly. Among serious vintage computer enthusiasts, the Sol-20 by processor technology is an icon. It wasn't the first to do away with blinky lights and switches or terminals, but it was one of the first to take the classic 8-bit wedge form that we all know and love, and thus was one of the first to look less like a mad scientist's project and more like something you could buy from a department store catalog. With its sturdy metal housing painted blue, its stained center-cut walnut sides, this was personal computing made more human. Steve Jobs is said to have looked upon the machine at one of the first personal computer shows in 1976 and remarked that it looked far more complete and professional looking than Apple's own product, the Apple I. Supposedly this influenced the design of the future Apple II a little bit. But before the Sol-20 terminal computer, there was the Sol Intelligent Terminal. This machine, pitched as a project in the July 1976 edition of Popular Electronics, was offered as an affordable intelligent terminal that had the potential to be upgraded to a full-blown computer, hence why the later Sol carried the word terminal in its full name. And this is a machine I'd buy in a heartbeat if I had thousands of dollars and if the only extant example wasn't now in the hands of a museum. The story of the Sol Intelligent Terminal prototype begins with two electronics engineers, one self-taught and one formally trained, Robert Marsh and Lee Felsenstein. The two men had known each other since their days at the University of California, Berkeley in the late 60s. Lee Felsenstein was born in April of 1945 and came of age as the flower power hippie revolution was in full swing in California. A young radical, Felsenstein affiliated with protest movements like the free speech movement, and even got himself arrested during the infamous Sprout Hall sit-in in 1964. A University of California, Berkeley electrical engineering student, Felsenstein was restless and briefly dropped out of school to work as a junior engineer for Ampex, a maker of things like reel-to-reel tape drives. But he resumed his education a while later and graduated with a Bachelor of Science in Electrical Engineering and Computer Science in 1972. Felsenstein showed signs of being an engineering prodigy early on, with a focus on making electronics more accessible to the mainstream, especially computers. Bob Marsh, on the other hand, earned a Bachelor of Science in Biology initially. Marsh had an entrepreneurial mind and was fascinated by electronics, so he taught himself electronics engineering. Intrigued by Don Lancaster's TV typewriter project, which was released in September of 1973, he built one of his own, but he found it tricky to keep operational and it wasn't really well suited to the task of being a computer terminal. Both he and Felsenstein had met while at UC Berkeley, but had not shared many interests or much contact during that time. The two men reconnected shortly after Marsh built his TV typewriter in 1974. At the time, Felsenstein was helping run the first publicly available electronic bulletin board system, dubbed Community Memory. Community Memory consisted of a mini computer and two strategically placed teletypes, one of them in a record store that provided public access to post messages and store information. There were plans to expand it, sort of internet-like, to other sites around California and beyond. Felsenstein, having checked out Marsh's TV typewriter, had actually begun designing a terminal of his own, which he hoped to deploy as a replacement for Community Memory's teletypes. A devotee of Ivan Illich, a priest-philosopher, Felsenstein strongly believed in the concept of conviviality, which he sought to apply to electronics design. The goal of Convivial design as applied to electronics was to make a product that encouraged the end user, who may or may not have deep experience with electronics, to explore, self-teach, tinker, and modify a device. Felsenstein hoped to apply these design principles to create new CRT-based community memory terminals that could be deployed far afield and easily serviced by those charged with administering them. Dubbed the Tom Swift terminal after the lead character from a series of sci-fi novels aimed at young people, Felsenstein's design never made it beyond a written circuit description. But the concept of conviviality would guide his design decisions for other products going forward, and some of the DNA from the Tom Swift circuit would make its way into what would become the Sol. In January of 1975, Marsh persuaded Felsenstein to join him in renting some industrial space in Berkeley. Marsh had plans to start a company producing something in electronics, maybe fancy digital clocks or something of that nature. Felsenstein would split the rent with him and would be able to get his workshop out of his house, as well as take some design contracts for the new company from time to time. Big things were happening in microcomputing in 1975. Micro-instrumentation and telemetry systems of New Mexico, also known as MITS, had introduced the Altair 8800, an Intel 8080-based microcomputer in the December 1974 issue of Popular Electronics, and was now producing it in earnest in 1975. The Altair as delivered didn't do much apart from blink lights, but its professional build quality, affordability, and expandability caused quite a stir. In a garage in Menlo Park, a group of hobbyists gathered to form what would be known as the Homebrew Computer Club to discuss this new machine and entertain ideas for improvement. From this small grouping of enthusiasts would come several microcomputing luminaries, people like Steve Wozniak, Steve Jobs, George Morrow, and some becoming founders of major computer companies. Lee Felsenstein joined as a founding member and served as the somewhat unruly group's moderator. Felsenstein took Marsh along to the second meeting of the group in the spring of 1975, during which a demonstration of the Altair was arranged. Marsh was deeply impressed and decided to form Processor Technology to produce add-ons and improvements for the new computer. Felsenstein helped out from time to time with schematics, manuals, and so on. Processor Technology even proposed their own 8080 board, which would effectively allow them to produce their own computer, but Felsenstein declined the offer to design it, and the project never got started. That summer, seeking a way to liberate Altair bus computer users from blinky lights and toggle switches, Bob Marsh decided to embark on producing what could be considered the first video card for a home computer to allow direct video output and keyboard input to the computer. Marsh contracted Felsenstein for the project, and Felsenstein dusted off the design for the Tom Swift terminal, specifically its video section, to create the new card. The Video Display Module 1, or VDM1 as it was known, was ready by the fall of 1975. It offered the promise of liberating thousands of hobbyists from painstakingly entering programs via toggle switch, or the noise, expense, and maintenance requirements of a teletype, or the cost and extra space required for a proper terminal. The VDM1 was a success for the young company, and it spelled the end for the teletype and front panel eras. In November of that same year, Leslie Solomon, the technical editor of Popular Electronics magazine, either sought out or agreed after some arm twisting to feature a product on a so-called intelligent terminal, and Processor Technology was given the task of pulling it off. Whose idea it was exactly remains the subject of debate, but nonetheless it set bigger things in motion for the two co-renting friends in Berkeley. If Processor Technology could pull the proposed project off, their machine would be featured on the magazine cover, and that would give the young company some serious exposure. An intelligent terminal was basically a computer terminal that utilized a microprocessor, thus enabling certain additional functionality, such as enhanced screen editing, that a conventional dumb terminal could not provide. Intelligent terminals are pretty much microcomputers in their own right. A few tweaks in an intelligent terminal design could convert the device literally into a computer, and that was definitely on the minds of Processor Technology's design crew. There are differing accounts of why Processor Technology simply didn't go and design a full-on microcomputer for the Popular Electronics gig. Some accounts suggest Les Solomon specifically wanted a terminal and not a computer, supposedly being tired of all the computer projects showing up in his and rival magazines. Other accounts accord with Lee Felsenstein's own, that what would become the Sol Intelligent Terminal was hopefully going to develop further into a computer, but concerned that they'd be unable to realize that capability by the magazine's deadline, they would initially aim for only a terminal. Between Marsh and Felsenstein, there was some disagreement about which way they should go. Felsenstein initially favored the dumb terminal route, with no microprocessor, to reduce the cost and complexity of the task. Marsh, however, favored an intelligent terminal design featuring an Intel 8080 microprocessor. The duo worked out some rough designs for each option, and in the end, Felsenstein said he was persuaded by cost to go with the intelligent route. The cost and complexity differential between a smart and dumb terminal had turned out to be quite minimal. And anyway, the intelligent terminal could be developed further into a microcomputer, which was where processor technology had always wanted to go. Developing a computer, or intelligent terminal almost from scratch in 6 months was never going to be an easy process, however. According to Felsenstein, he and another designer sweated it out in an upstairs loft of the rented warehouse space, using a custom-designed light table and 4x tape to lay out the design. The new machine was, from the start, to maintain compatibility with the Altair or S100 bus. However, to minimize the number of high-power tri-state drivers on board, the onboard memory and I/O devices would be disconnected from the S100 data input pins, and instead use a so-called low-drive internal bus to the CPU. A 4-way data selector or multiplexer could take data from the internal devices, an attached S100 card, as well as keyboard and parallel data inputs. The connector for the S100 bus would prove to be the most contentious aspect of the design, with Marsh, according to Felsenstein, repeatedly changing his mind about where to place it and how he wanted S100 cards to connect to the system. Originally, Bob wanted an external cabinet for S100 card add-ons, connected via a flat ribbon cable. The cables that this would require had a maximum of 50 conductors, or wires, in width, and Felsenstein strongly advised adding more ground return lines on top of that to minimize the signal noise problems present on the Altair. That would have required more than 100 wires, which was undesirable. But the duo hit upon a potential solution. They would take the data in and data out buses, connect them in parallel, and create a single data in-out bus. Thus, 8 wires could be used instead of 16. To control traffic direction, the Intel 8080's dbin signal, which was normally used to enable data input on the data in bus, could be used to halt incoming data and thus allow outgoing data to use the same wires, sort of like a traffic light for a single-lane bridge. This decision had consequences both good and bad. One issue was that many manufacturers of S100 gear didn't actually use the dbin signal, so that meant a fair number of S100 cards would not be compatible with the SOL. On the other hand, using the same wires to send and receive data meant that they had 8 spare wires available, which in the end would prove the difference between the prototype board design working or being unworkable junk. Another key design feature of the new device was the derivation of all clocks the system used to come from a single 13.4784 MHz crystal. Marsh's calculations showed that 3 clock speeds could be derived from that frequency, allowing the use of faster 2.5 and 3 MHz 8080 chips if wanted. Marsh did entertain the idea of using a faster crystal to allow for color video boards, but Felsenstein apparently talked him out of it. Another Marsh design point concerned the case. From the very outset, Marsh wanted it to have walnut sides. I'm not really sure why, but this was the 70s and lots of appliances and decor featured wood, sort of in tune with hippie sensibilities about earthiness. A friend named Steve, a woodworker by trade who had built a light table that the design team was using, was enlisted to source wood for this purpose. Steve suggested center-cut walnut, which was considered undesirable and thus available for cheap. This design feature is one of the few exterior elements that made it over to the production version of the SOL, leading to the joke that processor technology really existed to help sell unwanted walnut wood. The lid of the case would be smoked acrylic rather than the metal that would be used on the later SOL 20. Throughout the design and layout, Marsh frequently interjected with ideas and changes, which ordinarily would have greatly annoyed engineers. One addition he hummed and hawed about was a cassette deck. As the design of the prototype progressed, it became clear they were headed towards a computer after all, and data storage would be important. However, the design that had been settled upon contained no circuitry for encoding and decoding with tapes. So the cassette deck was basically a dummy placed in the cabinet for show, and the article that ultimately appeared in Popular Electronics made no mention of it whatsoever. One final design change nearly derailed the whole project. According to Felsenstein, at the last possible minute, Marsh decided to change which side of the board the S100 connector was to emerge from, opting for the top left corner. This required nearly 100 traces that had to cross over various other traces, a task that, owing to other traces and such being in the way, was not possible to complete. The end result was the need for nearly 100 jumper wires to make all the broken connections, just to get the thing to operate. It should be noted in designing the SOL Intelligent Terminal prototype, processor technology did not follow the practice of building the design in wire wrap first. There was no time for that. Instead, it was directly laid out as a PCB on their light table. According to Felsenstein, 2 copies were ultimately etched, one that went into the magazine prototype, and the other that remains in Lee Felsenstein's possession, testament to how hairy the design process got. After several months, the completed machine was handed off to software engineers who enabled it to do just enough to demonstrate the possibilities for the magazine. Having gotten the thing built, there remained the matter of naming it. The name Sol came about after Felsenstein suggested advertising the machine as having the wisdom of Solomon. This was also a cheeky jab at Les Solomon, the editor of Popular Electronics, who had suggested the project. Having made just barely the magazine deadline, as promised, Solomon made it the featured article for the July 1976 issue of Popular Electronics. The project was described in fairly standard terms, in just a few pages explaining all the possibilities the Sol Intelligent Terminal offered, including the possibility of becoming a full-blown computer. The article listed out the parts and offered builders a set of plans they could write in for. Finally, the article concluded with instructions on building the machine, which included the order of assembly and some tips on testing. And that was kind of it for the project. Popular Electronics moved on to other things, but the Sol Intelligent Terminal did generate a fair amount of interest from hobbyists. However, while a few sets of plans for the original design were ordered and sent out, very quickly processor technology shifted gears and entered a redesign, this time with the explicit aim of creating a computer, but also with the goal of fixing the mistakes of the original. A letter to hobbyists went out very quickly after the article appeared to advise that they shouldn't build the old design, but instead wait for the new one. The new design would not offer artwork for hobbyists to etch their own boards, but rather offer a professionally manufactured PCB hobbyists could build on. This would be available for a time as just the board by itself. However, processor technology eventually would allow it only to be purchased as part of a fuller kit. The resulting Sol terminal computer thus arrived in a few flavors. The Sol PCB, which was just the newly redesigned board, the Sol 20, a full-blown computer, and a cut-down version called the Sol 10. The new board design bore little resemblance to the original. The S100 connector was moved from the outer left edge of the board to the center, and a swappable personality module with EEPROMs containing the system's firmware replaced the socketed EEPROMs of the prototype. I have a Sol 20 myself and love it, even though in advancing age it's gotten increasingly cranky. It's big, it's loud, it's heavy, and the internals kind of look like something from Mad Max, but it's a key stepping stone in the development of the classic 8-bit personal computer. And I think it's just gorgeous to look at, with its blue metal case and walnut sides. Bob Marsh was definitely onto something there. That said, there is something about the prototype, like most prototypes, that is special. It's the Sol as it sprang from the hands and heads of its designers. It's a little bit rough around the edges, like the rushed process that summoned it into being. I'd really like to have one on my shelf, but of course there is only one in existence, and it's never going to be for sale. I'm not aware of anyone actually building a Sol Intelligent Terminal other than the creators. With the short window between the two PCB designs, I think it's unlikely anyone actually bothered. So I don't think one will ever come up for sale, leaving me with a choice: appreciate it in pictures, or drawing on my experience having built a replica of Don Lancaster's TV typewriter prototype, build one for myself. And naturally, I've selected the latter option. Boy, am I in for it this time. So obviously, embarking on something like this, the first question people ask me is why? Why am I spending money building something that is completely obsolete and was ultimately replaced by something I already have, which works much better? And I'm kind of used to that. I ran into those questions with my TV typewriter prototype replica here. I had a lot of people saying to me, well, why don't you just make a really nice case and stuff a Raspberry Pi in it? And the reason I didn't do that is because I didn't want a simulated experience. I wanted the real thing. And part of my thinking behind that was, it's not just about the device itself. I mean, I love having this, but it's also about the experience of building one. I wanted to kind of time travel a little bit and go back into, the early mid 70s and try and build something somewhat as someone would have back then. Now, obviously, not everything is going to be exactly the same in terms of process. There are certain things that they were doing back then that we can't do now, like developing photo negatives from the artwork. Some of the processes just aren't available. And of course, I did bring to bear some modern advantages, like using Photoshop to tweak the artwork after I scanned it in. So yeah, obviously it's not a fully authentic experience, but you know, it's pretty close. And I live in a house that was built in the 70s, so it does kind of look the part. So yeah, the experience was one part of it. And then again, having the physical thing meant something to me as well. And I did kind of luck out big time on this because the exact correct keyboard that Don Lancaster used back in the 70s became available. This is a micro switch keyboard. There were just a couple of them that came up on eBay one day and then never again. And I just managed to snag one, and then I redesigned it the way Don did and turned it into what we have here. And yeah, some of the parts were really difficult to find, like the shift registers. I was down to literally the last supplier out of like dozens that I contacted, and they just luckily had some. So you know, there definitely are some challenges to going this way, but on the flip side, it's kind of fun. It's kind of like doing a treasure hunt where you're looking for things that other people can't find, and then you find them and you're like, yes, I've got it. Now, of course, it could have turned out the other way. I might have ended up not being able to find the right parts and might have been stuck. But I find if you search long and hard enough, you'll eventually find what you're looking for. And the result, yeah, I mean, if I do say so myself, when I went into this TV typewriter project, I had absolutely no idea what I was doing. I was just like, oh yeah, I'm totally going to build that. I'm going to make those circuit boards again. I'm going to find all the components, I'm going to put it all together, and it's just going to work. And it's going to look exactly like the prototype that's down at the Computer History Museum. Just pulling stuff out of thin air, you know, no problem. I'll just make it work. But I did. I think this is as close as you can possibly get. I'd love to put this next to the real one sometime down in California, but unfortunately that's a long drive, so that'll have to wait. Now, the difference between this project and doing this build of the prototype for the Sol is this project was actually sanctioned and it was properly vetted out. You know, the PCBs didn't have any errors in them, and people were actively encouraged to build this. This one, on the other hand, pretty much the second this article came out, Processor Technology was already redesigning the board, and the people that got the construction guides, the few that actually ordered one, got a letter from Processor Technology saying, don't build this board. Even though we're sending you these plans, don't build this board because it won't work. Wait for the new one. But for me, that kind of just adds the challenge factor to it, because it's like, okay, I can do something now that other people can't do, right? I have this keyboard, which is pretty much the same one that was in the prototype. So that gives me an option that most other people don't have. It certainly would be easier if I went and did some other project like, an Apple I replica. I actually bought a Newton One board to do that. But I'm one of those people that kind of likes to follow the road less traveled. And right now, the Apple I is probably one of the most common replica projects out there. I mean, literally, there are people that are mass producing these things, wave soldering, the whole bit. And it just kind of lost that specialness to me. So I thought, for the first Raising the Digital Dead episode, I want to go for the whole 9 yards and really try to find some project that really puts me to the test. Now, that being said, I have been forewarned by Lee Felsenstein himself. This is probably not going to work. There's more than 100 jumper wires, which you can't see in the photos of the prototype because they're underneath the board. There are some that are above, but most of them are underneath to stay out of the way of the camera back when it was having its pictures taken for the magazine. So yeah, that's going to be a challenge. I'm probably going to have to, try and follow the schematics and painstakingly figure out where they didn't make the connections. My understanding is the schematics are good, but the PCB design itself isn't, owing to the fact that Bob Marsh at the very last minute changed the location of that S100 slot. And it was just simply a case of they already had most of the board laid out and they just couldn't make all the traces reach the slot because they were going over existing traces and there was nowhere on either side of the board to do that without running into something. So I'm kind of approaching this kind of the way that Lee himself suggested, which is just as a work of art. I'm trying to create something that will sit on my shelf just like this one does and look convincing and, just be there as an example of an historic machine and something that I created with my own hands, which is, something you get real enjoyment out of. Now, I am, like I said, going to try to make it work, obviously. I mean, that's part of the challenge. And, I am going to try and follow the schematics and make whatever jumper or wire connections need to be made. But I'm ready to accept it as just a static piece. And that's fine, because the original one doesn't work either. It basically worked for the brief period that it needed to do its demonstrations, and then that was it. They tried to fire it up some years later and it wasn't working. So that's kind of the plan. I'm expecting it to be quite a bit more difficult than the TV typewriter, just because, I have to figure out how to build this chassis that looks like the one that they had. It's got a slightly more involved metal pan. This one is basically just a single piece of metal that's bent up in basically a U shape. The other one's got all kinds of bends in it. It's got the brackets to mount the keyboard. I've got a guy that I'm pretty sure can handle that stuff, so it's really just down to me getting the basic layout of it correct. And of course, that's another challenge. I don't have access to the actual prototype. It's down in California. I doubt they'd allow me to take it apart to the degree that I would like to in order to verify the dimensionality of everything and see everything. So yeah, it's just another challenge on top of all the other challenges that are going to come with this. And, if it turns out half decent, I'm going to be happy with that. It's, it is what it is. I've been warned. I know it's going to be difficult. I know it's probably not going to work, but the possibility that it might work is really exciting to me, because I've always kind of liked alternate history type things. And I think it would be really interesting to pretend to be a hobbyist of the day who's just trying to replicate what's in the magazine, and then maybe takes it a step further, because this machine was originally designed as a terminal, not as a computer. It could be upgraded into a computer with a bit of work. Now, of course, even if I get the wiring issues and everything sorted out and I manage to get the thing to turn on properly, I'm not going to be able to actually run the original firmware that the machine had when it was delivered to Popular Electronics. And the reason for that is, unfortunately, there were 3 EEPROMs that had that firmware, and one of them was physically broken. So we have the data from the first 2, but not the third one. And the third one is the one that the first one jumps to immediately to start up. So we don't really know 100% what functionality the machine had. So there's kind of a couple of different options. One is we could potentially try and recreate, just based on guesswork, what it did. But the other thing we're thinking about doing, and I've talked to my friend Dave on VC Fed, and he's volunteered to do this, is actually get the thing built and port console, which was, I think it was the first firmware for the Sol 20, and basically port that over to this prototype machine and actually follow through and make it a functional computer, which is the alternate history idea. So yeah, I'm pretty excited about that. I'm really excited about this series. I hope you are too. This was originally going to be a 1-hour video where I did the history, laid out the process, and then built a cardboard prototype. Unfortunately, that last part took a really long time, and I really wanted to get this video out for Halloween for whatever reason. I mean, it's raising the digital dead, why not? So I've broken the video up, and this is where this video will stop. And then as soon as I possibly can, I'll have part 2 up. Part 2 will basically lay out some of the challenges and some of the things that I ran into with the TV typewriter project I did, and drawing on that experience, how I propose to get through building this all intelligent terminal so that it looks just like this one. And then, of course, I'm going to show you the cardboard prototype that I've built of the case. I actually built the case for my TV typewriter first, and I'm going to do it again for this one, just because it provides a little bit more motivation. I find when I had this built and I had it sitting on my desk, it confronted me every single day, and that kind of motivated me to keep going and keep finding the parts and keep building the thing. And that's what got it done. So that's kind of why I'm going at that approach first. And in the meantime, I'm acquiring parts and stuff like that. And then in subsequent videos, we'll go over, how I build it. It's the kind of thing I wanted to do with this TV typewriter, but I just was too impatient. I wasn't fully on YouTube yet, and I just didn't have time. So we're going to do it this time. And yeah, hopefully we will end up with a functional Sol prototype. And who knows, maybe one day I can take it and this thing down to the Computer History Museum, put them beside the originals, and see how close we got. Anyway, that's it for this video. Thank you so much for watching, and we will see you in the next one.